All right, guys, Mr. Antonucci here, and this is question number 6 from the 2021 AP Calculus AB exam from Administration 1. Remember, this year they had 3 different administrations. They've released this one from the first one, and so we're going over the solutions. Now, as of the date of this recording, they had not yet released the scoring guidelines. So again, I don't know what the point breakdown is, other than you probably get 9 points total for each question. I'll give you some pointers as to how I think some of the questions are graded and what points you would get for what. But again, it's just my opinion, but I've been teaching AP Calc for over 15 years, so I have a lot of experience. But anyway, let's jump in. Number 6, a medication is administered to a patient. The amount in milligrams of the medication in the patient at time t hours is modeled by a function y equals a of t that satisfies the differential equation there. At time t equals 0 hours, there are 0 milligrams of the medication in the patient. Portion of the slope field for the differential equation is given below. Sketch the solution curve through the point 0, 0. Now, when you're given a slope field or a direction field, and they ask you to sketch the solution, what they want you to do is make sure that your solution begins at the initial condition they give you, and then how you sketch the curve is you follow the slope tick marks and you kind of make your curve go parallel to the tick marks and follow the pattern here. So you can see that this graph is going to basically be increasing and concave down and have a horizontal asymptote right around right here. So if we begin to sketch this parallel through the curves here, doesn't have to be exactly perfect. And in fact, I'm going to erase a little bit of that. What you definitely don't want is to cross that horizontal asymptote. You don't want it to go like this or anything like that, because that definitely wouldn't be a function. And you want to follow the tick marks. And you also want to make sure that your curve, your solution curve, passes through the condition that they give you 0, 0. My guess is they're going to give you 1, maybe possibly 2 points for this question. Let's carry on. Using correct units, interpret the statement limit as t approaches 0 of a of t equals 12 in the context of this problem. Instead of writing it out, I am going to verbally say it for you. Now, you have to get everything in terms of the limit statement and also the units of the problem and the number 12. So t approaches infinity would mean as the number of hours since the medication was administered to the patient increases without bound. Okay, so that's how you interpret that limit part, as the number of hours. And in the context of the problem, A of t models the amount of medication in the patient at t hours. So if you're doing the limit, you're looking at what happens as t gets infinitely large. So this is saying as the number of hours since the medication was administered to the patient increases without bound, A of t equals 12. So the amount of medication in the patient approaches 12 milligrams. Okay, so a lot of that is important. I'm going to guess they're probably going to give you 1 or 2 points, probably 2, because there's a lot going into this limit statement here and the context. You probably have to have what the t approaches infinity means in terms of hours since the medication was administered to the patient. And the equals 12. You have to probably interpret that as approaching 12. 12 what? In the context of the problem is 12 milligrams of medication in the patient. So part C, if we just slide down here a little bit, use separation of variables to find y equals a of t, the particular solution to the differential equation dy dt, with initial condition a of 0 equals 0. Now, before I forget, I just want to show you that there is a part D to this question that was on page 2. So just be careful about that, and I'll make sure to go over that part as well. Okay, let's see if we can squeeze it all in. It says use separation of variables and the initial condition 0, 0. So to separate, you have to get your dy and your y on one side and your t and dt on the other. So I divide by this quantity and multiply by the dt. So dy over 12 minus y equals 1/3 dt, because the 3 is in the denominator there. Anti-differentiate both sides. 1/3 t, I like to put my plus c on the right side. And the antiderivative of 12 dy over 12 minus y is going to be negative natural log absolute value of 12 minus y. Okay, so just be careful right there. And then what we can do, and the reason this negative is here is because if you use u substitution, the u would be 12 minus y, so your du would be negative dy. The negative's not there, so you have to adjust for it, so forth and so on. Now, what I'm going to do is use the initial conditions that when t is 0, y is 0. So negative natural log of 12 equals, well, when t is 0, that would just be equal to c. So they want to see that you get the initial condition c. So we can plug this back in now and get negative natural log of absolute value 12 minus y equals 1/3 t minus natural log 12. You could divide off this negative, that would make this negative and this positive. And then we exponentiate both sides. The e and the natural log cancel. You'd have absolute value of 12 minus y equals e to the negative 1/3 t plus natural log of 12. And if you remember your rules for exponents, when you're adding in the exponents, I'll just do it up here. You can write it as multiplying like bases. So e to the negative 1/3 t times e to the natural log 12. And this would cancel, giving you a factor of 12 in the front there. So here we go. Let's make this go up here. So notice I haven't handled the absolute value part yet. So this would be absolute value of 12 minus y equals 12 e to the negative 1/3 t. Since you have absolute value here, when you take them off to solve for y, okay, that means the inside the absolute value has to be equal to 12 e to the negative 1/3 t. However, since the absolute value is there, that means this could have been plus or minus. Now back here, when they gave you this initial condition, the initial conditions will tell you and determine whether or not you want the plus or minus. Well, if t is 0, this would be e to the 0, which is 1, which makes this 12. And y is also 0, so you'd have to have this have 12 equal 12, and the only way that's going to happen is if you just have positive 12. Okay, then you can add the y to this side and subtract the 12e to the other side. So you have y equals 12 minus 12e to the negative 1/3. Bippity bop, bippity boop. There we go. Usually this portion has like 4 points. They want to see that you separated. They want to see that you got the correct value for C or use the initial condition. They usually check to see if you have the correct antiderivative, and then they usually see if you solve the equation for Y. Okay, and this would be, of course, A of T. I think if you use Y instead of A of T, they're not going to get takeoff points for that. So finally, we get to problem D. So let's check this out. Okay, so with problem D, a different procedure is used to administer the medication in the second patient. The amount in milligrams of medication in the second patient at time t hours is modeled by a function y equals b of t, capital B, that satisfies this differential equation here. At time t equal 1 hour, there are 2.5 milligrams of medication in the second patient. Let's pause right there. So that would be like the 0.1, 2.5. Is the rate of change of the amount of medication in the second patient increasing or decreasing at time t equal 1? Give a reason for your answer. Now, the first time I looked at this, I made a mistake. And all I did, I saw increasing or decreasing, and I plugged the initial condition into the derivative, dy dt, and answered the question. But you have to be careful. Look what it says. Is the rate of change, so that's dy dt, of the amount of can't talk today, of the amount of medication in the second patient increasing or decreasing. So this is asking if the rate of change itself is increasing or decreasing. And in general, in calculus, when you're trying to determine any function, first, second, third, fourth, 18th derivative, whether or not that is increasing or decreasing, you have to look at the sign of the derivative of whatever function you're trying to determine is increasing or decreasing. Therefore, you're trying to see if dy dt is increasing or decreasing at t equals 1. So we have to take the derivative of it, because the sign of the second derivative will tell us whether or not dy dt is increasing or decreasing. So the derivative with respect to t of dy dt is equal to d squared y over dt squared. So we're basically just doing the second derivative. You don't need both of these notations. I'm just kind of putting that there for your benefit. So the derivative of the constant 3 is just 0. Then you have minus, and I'm going to leave that out front, y over t plus 2. You'd have to use the quotient rule here. Derivative of the top, derivative of y is dy dt, times the bottom, t plus 2, minus the derivative of the bottom, which is just 1, times the top, y, over t plus 2, the bottom, squared. Okay, now let me show you some tricks here. In order to evaluate d squared y over dt squared at the point, what was it, 1, 2.5, those are the t and the y values. We can plug those in. So you would have negative dy dt, t plus 2, so 1 plus 2, minus 1 times y, the y value is 2.5, over t plus 2 squared, so 1 plus 2 squared. Now the temptation, and it wouldn't be wrong, is to plug dy dt in terms of x and or t and y into this equation, and then plug in 1 and 2.5. But to make life easier, we could just figure out, okay, dy dt at the point, oops, you can't see that, can you? Let me move it over a little bit. What I'm going to do is figure out the value of dy dt and just plug it in here. So let's do it here. Dy dt evaluated at the point 1, 2.5 is 3 minus the y value, 2.5, over t plus 2, 3. Okay. All right, so 2.5 is like, that's 7 halves. So that'd be minus 7 halves over 3, which is 3 minus 7 sixths. So 3 is 18 sixths. So this will be 11 sixths. That's the value of dy dt. Hold up a second, we have a mistake. 2.5 is actually 5 halves. So this would be 5 halves here, which would make this 5 sixths. And then you'd have 18 sixths minus 5 sixths, which gives you 13 sixths. Okay, and that's the value of dy dt. So this would be negative 13 sixths times 3 minus 2.5 over 9. Now, 13 sixths times 3 is going to be 13 halves, which is the same as 6.5. Minus 2.5 is going to be a positive number. Divided by 9 is still going to be a positive number, and then multiplied by a negative. So this is going to be less than 0. Okay, so since the second derivative is negative, you would write this out in a sentence. Since the second derivative is negative, dy dt is decreasing, so the rate of change of the amount of medication in the second patient is decreasing at the time t equals 1. All right, well, hope that was helpful to you. Oh, the point breakdown. They'd probably give you a point for getting the second derivative, giving you give you another point for your explanation for this one. That's just my guess. They may give you 3 points, just depends. But I know you'd probably get at least a point for using the second derivative and a point for your reason, as long as it's correct. All right, guys, hope that was helpful to you. If so, please give me a subscribe and hit the bell for notifications so that you can know when new videos are uploaded. And if you have not taken the AP Calc exam, or if you're watching this, at some point way after I recorded this, preparing for another year's AP Calc exam, really hope this helps you out, and let me know how you did. All right, take care.